So today let us discuss modular arithmetic. Modular arithmetic is the fundamental building blocks of most modern public key crypto system. Public key crypto systems is a method for secure communications that uses a pair of keys, a public and a private key. Both the sender and the receiver has this public key and the private key. Public key is made public, is known to everyone, so it is shared openly and it is used for encryption. And the private key is known only to sender and receiver, and it is used for decryptions. Example of public key crypto system is RSA, Diffie-Hellman key actions, ECC, etc. So in a simple way, modular arithmetic can be defined as a system of arithmetic for integers where numbers wrap around after reaching a certain value called the modulus. A simple way to think about it is a clock. On a 12-hour clock, after 12 comes 1, 2, 3, so on till 11 again. Here the modulus is 12 because wrapping around happens at 12. So instead of counting normally, numbers reset after a fixed limit. So the fixed limit is here is a 12. So the basic idea is given any positive integer n. Suppose n is any positive integer and any positive integer n and any integer a. This a is also integer and n is also positive integer. So n is any positive integer and here a is also integer. So if we divide a by n, okay, suppose, so in cryptography and number theory we use this symbol a divides n, that is n divides a. So n divides a, this symbol, this vertical symbol, n divides a, then we will get a quotient q. So this is a quotient, and a remainder r. Suppose this remainder r is this is a remainder. So we can write the relationship as a is equal to q into n plus r. So this here 0 is less than equal to r less than n, and this q we can write as q is equal to floor a by n. So this is a floor symbols. For example, a is equal to 11, n is equal to 7, r is equal to 4. So we can write this 11 is equal to, and the quotient is 1 into 7 plus, here the remainder is 4. And we can define this remainder as a mod n. So we define a mod n to be the remainder. Then we can write the above expression as, suppose r is equal to a mod n. Then we can write the above expression is a is equal to a by n, a by n into n plus a mod n, where r is equal to remainder is at mod a mod n. So we can express as 11 mod 7 is equal to 4. And two integers a and b are said to be congruent. Two integers, and we can write this. Two integer a and b are said to be congruent if so two integers a and b are said to be congruent are said to be congruent modulo n if a mod n is equal to b mod n. So this can be written as a is congruent to b mod n. So the example, so I can give you some example, that is a, and this means this a is congruent to b mod n. So, or we can say that a and b leave the remainder a and b leave the remainder when divided by n. When divided by n. For example, so I can show you some example here. Example, 17 mod 5 is equal to 2. This is example. Example 2 is 23 is equal to, is congruent to 3 mod 10. That is both 23 and 3 leave remainder 3 when divided by 10. Or if we consider a clock, on a clock, "15" is congruent to 3 mod 12. This is, we consider 12-hour clock. Here we consider 12-hour clock. Okay. Then 16 is congruent to 4 mod 12, and this 13 is congruent to 1 mod 12. So we can, so on, we can write. Okay, so 12-hour, we can do 12-hour clock. So in next class, we will discuss the various properties of modular arithmetic and how to find the modulus of a negative number and a fractional number. So let's stop here for today.